Okay, hi everybody, and welcome to this Friday Facebook Live demo. My name is Stefano Gridelli, and I'm a co-founder and CEO of NetBees. Today, we're gonna talk about the ARP Flux, which is kind of a event or setting that happens in a Linux system with two network interfaces. But before telling you more about ARP Flux, let me give you some background about why ARP is needed. ARP is the address resolution protocol and allows to translate IPv4 addresses into layer 2 Ethernet or MAC addresses. And this is needed when you take an IP packet, you encapsulate on an Ethernet frame, and then you send that frame within your local area network. So again, the ARP address resolution protocol allows computers to translate IPv4 addresses into MAC addresses to basically send frames on the network. So, and how ARP, the way it works is that, let's imagine host A has to communicate with host B. So more specifically, send a frame to host B. And they're connected, of course, in the same subnet. So host A doesn't know the MAC address of host B, but does know the destination IPv4 from the application. So what it's going to do is going to send a broadcast Ethernet frame with the address FFFF, all F, basically. So a broadcast frame is processed by all the hosts in that same network segment or subnet. And basically, like host A is asking, hey, what's the MAC address associated to, in this case, 192.168.123. And the host B, which is the destination host, will say, hey, you can find me at this MAC address. Then host A, now that he has the destination MAC address, will encapsulate the IPv4 packet into the layer 2 MAC with the correct destination MAC address using his own MAC address as source address. Okay, and this basically, if you want to check what are the MAC addresses associated to the host within your subnet, if you're on macOS, you can just type ARP space -A, and you see all the ARP cache. Because of course, dynamically, your host will build this ARP cache as it establish communications with the host in the same subnet. One entry that for sure you'll see is the MAC address of your gateway, because all the packets that are not destined to the same subnet will go through the gateway. So as destination MAC address, you'll see the gateway's MAC address. Okay, so what happens with ARP Flux? ARP Flux is a kind of weird situation that happens when a host has two network interfaces on the same subnet. And you see always more this happening with maybe data centers or Linux system that maybe runs containers or run very specific type of application stack on top of its own base operating system. In Linux, we have a similar situation with the wireless agent, where you could have the Ethernet, which is used as control channel, and the WLAN 0, which is used as a testing channel for wireless testing on the same subnet, because sometimes our customers have, both networks on the same subnet, using the same subnet, like in the case of a small office. But in any case, going back to the Flux, what happens is that when the source host A, in this case, requests the MAC address of the destination host, host B could eventually reply. Let's imagine this packet is destined for the IPv4 associated to ETH0, so .1.23, right? In some situation, host B could also reply providing the MAC address associated to ETH1, right? And that's the default configuration setting of the Linux kernel, where it will send out the MAC address of whatever interface received before the ARP request, bottom line. And this could cause application issues or interruption of communication between two processes, especially if your host B has maybe firewall rules or some routing or forwarding decision strictly bind to a specific interface, right? So as you can see here, host B is now providing for the interface ETH1 is providing the MAC address of ETH0, bottom line, as you can see. So this is something that in most of the situation maybe cannot be a problem, but where is not desired behavior, you want to prevent this. So I want, for example, that ETH0 only provides its own MAC address, and the same for ETH1. So if you want to do this, there is a simple kernel, two simple kernel parameters that you can change with syscontrol, and here is the command you can type on your Linux operating system to avoid the ARP Flux behavior. And again, but if you push these two commands, you will get the correct behavior where ETH0 will only reply to ARP requests associated to its own IP address, and the same for ETH1. Now, I'm sure this is not very easy, it's a little complicated, so I also included here on this slide, maybe take a screenshot, or we'll also post this link on our Facebook page under this video. But if you want to get more information about these two commands, check out that wiki page on the linuxvirtualserver.org website. And also, I wrote a couple of weeks ago on our blog, netbiz.net/blog, an article about ARP Flux explaining like this behavior. Just go to our blog, search for ARP Flux, and you get the blog post. And if you have questions, of course, feel free to ask on our Facebook page or netbiz.net on our website. With that said, I hope this was educational and informative. As always, thank you so much for attending our Friday Facebook Live demo, and have a great weekend.